That's what we're doing. So let's see. Last time, real quickly, we had 4 different ideas. We had the L'Hopital, powerful way to find limits. We had linear approximations, nice idea, find a tangent line. Degree 1 sketch, figure out the uphill, downhill business. And then the degree 2 stuff, nice way of adding curves to your previous sketch. Very nice graphical interpretation of the second derivative. It adds this curvature, concave up or concave down. Concave up, concave down. Well, it's hard to do that. That's what we've been doing lately. What we want to do today is add yet more stuff that we can do with derivatives. We want to add a fifth one, and this one's especially nice because it's a tribute to one of the greatest minds that have ever been produced by the human race, the mind of Sir Isaac Newton. This one's for you, Isaac Newton. This is attributed to him, and it goes something like this. The theme is solving equations, and there are a few easy equations. For example, this one, it's not so bad. Any old chump can solve it. Maybe you do something like this. You go x plus 2, x plus 1, whatever. That's easy to solve. X equals -2, x equals -1. That's not that big of a challenge. Even these things, you have the ultimate weapon, negative b plus or minus the square root of b squared minus 4ac all over 2a. For degree 2, we've got the ultimate weapon, the quadratic formula. But right after the quadratic formula, it starts to get a little bit more interesting. For example, degree 3, you can't use the quadratic formula because it's degree 3. So what can you do? Well, even this is still doable by humans. A long time ago, people tried to do these and they worked on them for hundreds of years until somebody got smart and they have some sort of cubic formula. Cubic formula, it's sort of a template in much the way that the quadratic formula is a template to solve all of them. So you just look at your coefficients. 1, there's 0x squared, there's 3, so you just plug it in. X equals blah 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 blah, and x equals blah 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 blah, and x equals blah 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 blah. Degree 3 will have 3 solutions. And if you've never seen the cubic formula, well, maybe I don't know. They don't usually do it in schools, at least at this level, because it requires a little bit deeper ideas. Maybe someday I will put it here on Math Hands. I would love to do it and explain it, but well, so many formulas, so little time to explain them. Let's just let that slide. There is a cubic formula, but it's not that easy. So in fact, this already becomes pretty challenging. A couple options that we have at this level, typically for at least the type of education around here, you might have the factor by grouping. Sometimes you can do that. You might be able to factor by rational root theorem. Every once in a while you get lucky and it's a rational root. But generally speaking, this is no enchiladas. This is not that easy. And so what I'm trying to persuade you to believe is that the business of solving equations, it's not an easy business. It's a tough business. Even degree 4 like this, a polynomial, what do you think? Is there a degree 4 formula where you could just plug in the 1, the 2, the 7, and the 1 into some formula and it'll give you all 4 answers? The answer is yes, there is some for degree 4 formula. Have you seen it? I haven't seen it. I'm just kidding. Typically, students at this level who've had, all the way through pre-calculus, they've never seen this. It's not typically done. But there is something out there for it. Still, without that, it's a very challenging problem. Again, sometimes you can get lucky and you can do factor by grouping or recognize it's a famous one or rational root theorem. But if it's none of those, you're pretty much out of luck. And there is some formula out there. Maybe I'll do it later. Some degree 4 formula. I would love to do it. But that's no enchiladas. That would be a serious one. That'd be like for a whole weekend when you got nothing to do over the whole weekend. We would do this video. Degree 5, again, it's really difficult, but degree 5 has an interesting story. There was once upon a time a guy here, and he was a young fellow, maybe 17 years old or something like that. Maybe 19, I don't know. A French guy, and he was in love. Was in love with this girl here, and she was really pretty. She had hair that came down to her shoulders, and always a big smile. And he was in love with her. Love. And this girl, but some other guy was also in love with her. and everybody loved this girl because she was so hot. And so then we had problems. This guy hated that one because they both loved the girl, and so they said they were gonna have a duel here, and they were gonna shoot it out here with guns. That's a gun, by the way. Yeah, I know. And they're gonna shoot each other, and they're gonna have a duel. And so this guy, the 17-year-old, the interesting guy, on the night before the duel, just sat down, and he was really concerned because he was gonna have the duel the next day. He was so concerned because he thought maybe that might be his last day on Earth. And so what he did that night is he stayed up all night with little candlelight and whatnot, and all night he just started writing papers. And what he was writing was math papers and math ideas about the degree 5 formula. I know, huh? It's crazy, but it's true. That night, before the duel, this guy sat down and said, you know what? No one has found a formula for degree 5. But, there's more than that. No one has ever found a formula, and no one will ever will. No one ever will. Never, ever, ever. He proved that you cannot, in the same way that you found formulas for the other ones, find a formula for degree 5. No one will ever, 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 for eternity, for 5,000 years, for 5 million years, no one will ever, ever find such a formula because it doesn't exist. That's some deep stuff, man. They call him a genius. Of course, they call him the dumb genius because he died the next day. But he made his mark in the world forever. And so now everybody knows that that's where the buck stops. There's no degree 5 formula. These ones, solving equations is tough business, but even this one we can handle. That one we can handle. That one we can handle. Oh, degree 5, forget about it. There's no formula for that. Of course, that guy's name is Galois, a famous French guy, Évariste Galois. At the age of 17 or 19, he died doing some crazy stuff. Yet he was a genius, which shows you even a genius can have dumb ideas. All right, so where does that put us? Well, those are the easy ones. Those are even the easy ones, the degree 1s, degree 4s. You know, these are polynomials. Imagine how crazy it would get if we added a little more to the mix, like logs and absolute values and little exponential stuff with some trick stuff. Solving this would definitely be a huge challenge, and I love it. Solving that would be very, very, very challenging, and that is why the business of solving equations is a tough business. Can't tell you how tough it is. Only in a few cases can we really do something good with these solving equations. Only in a few cases, like polynomial stuff, degree 1, degree 2, only degree 4. Everything beyond that is a weekend project, or at least. So anyways, but the story continues here. Let me get back to the story here. Story is about what can we do with derivatives. Well, we did all this stuff. What we got to do today, this is item number 5. Well, item number 5 in blue. Item number 5, we got to solve equations. We're taking on the tough business of solving equations, and of course, we're not doing it alone. These ideas are inspired by the great genius, the God disguised as human, Mr. Sir Isaac Newton from the 17th century. He gives a big blow to this problem of solving equations, and he does it in such an elegant way with just one little thought, one sentence. Often, this is what changes the world, buddy. Boys and girls, this is what changes the world. Just one little sentence, one little spark of genius, one little idea, boom, it changes the world forever. Isn't that crazy? I know, huh? I can't wait till I have one of those ideas. Here's Newton's idea that changed the world. Sir Isaac Newton. He said, you know what? Suppose I've got some function here, some crazy function that's tough business to solve, but suppose I know it goes through 0 around some point here. You could do that by using common sense or intermediate value theorem. We'll talk more about that later, but suppose you've got some idea of the graph, or you could do it using the graphing techniques that we just got done doing not too long ago. Anyway, suppose you have some idea of the graph, and suppose you could somehow get close to one of the answers. Suppose you could somehow deduce that, hey, I know that if I start at 2, I'm not too far away from the answer. Maybe this number over here is 1, and this number is 2. Maybe between 1 and 2, I'm not too far away from the answer. Somewhere between here, 1.5, or somewhere here, I've got myself an answer. Right? Use common sense to get a first starting point. And then what we do is we're great at finding the tangent equations, right? So right at this point here, I will find the tangent equation. Tangent equation, of course, we've done it so many times, but I love doing it, so I'm going to do it again. The tangent equation is given by two ingredients, the point and a slope. Of course, the point on there would be 2 comma f of 2, and the slope would be f prime of 2. Therefore, that equation would be y minus f of 2 is equal to the slope times, how many times have we done this? We're going to do it many, many, many more times. You better get used to this. This is so, so important. F of 2 plus f prime of 2 times x minus 2. That is, my friends, the equation for the tangent line at 2, assuming that such a thing exists. Here, I'll repeat it one more time, and that one's so, so important. Let's put it in red here. At any given point, the tangent line is given by f of c plus f prime of c times x minus c. Rack that. That's super, super important. We've done it many, many times. Not only just memorize it, but know where it comes from. It comes from a simple idea back from algebra on how to write the equation of a line when you know the slope and the point. Capiche? Alright. That's nothing. We've done that before. What does Newton bring to the table? The genius. Well, Mr. Sir Isaac Newton, I like saying that. I should do it on there. It shows respect. Mr. Sir Isaac. I don't know how to spell Isaac. Whatever. No, not whatever. Sorry. Sorry, Mr. Newton. Sir Isaac Newton, the brilliant idea, the brilliant man. One little thought changes the world. Watch this. He says, you know what? I can write the tangent line here because I'm great at derivatives. I invented them. That's what he would probably be saying to himself. Damn, imagine saying that. I invented derivatives. That's better than Chuck Norris, huh? All right. One brilliant idea is all it takes. Here it is. Mr. Sir Isaac Newton says, hey, you know what? This thing right here, I got the tangent line. This thing is pointing me in the right direction because the graph mimics the function. It's telling me it's going that way. Why don't I just follow that line? Boom, follow it. And it'll lead me closer and closer to the right solution. It's telling me, hey, go that way, fool, it's that way. And so what I do is I extend this line. Get a little excited here. I extend this line and I say, hey, I'm going to extend it here and find this point right here, exactly this point right here. And then I will have gone closer to the solution. Oh, but that's not even it. Wait, there's more. Well, suppose I call this my x1, my first starting point. Suppose I call this x2. It gets better than this, watch. Should I zoom you guys in or not? Yeah, I'm gonna zoom you. No, I can't. Forget it. Okay, so then it gets better. He says, you know what? I can do even better than that. What I'm going to do is I'm going to take that point right there and I'm going to go up to it, to the top here, and start all over again. At that point, at this point right here, I will find a tangent line again. And the tangent line will look something like this. And I'll call this tangent line, I'll call it something else. If I call this my first tangent line, I'll call this one my second tangent line. And then this tangent line will tell me, hey, go that way. You know, I'm mimicking the graph for you. You see, it looks like this. Go that way. And I follow this line, and I intersect it with y equals 0, and boom, it tells me another point, x3. That's a beautiful idea, x3. Because you know what I'm going to do? I'm going to do it again and again and again. And this process will take me ever so closer and closer and closer to the sweet spot here. This process of finding a solution, going up there, finding the tangent line, going up there, finding the tangent line, going up there, finding the tangent line, and coming back over and over and over again. That's it right there. Reducing that process infinitely many times, or as many as you want, you can get as close as you want to the actual root. And that, my friends, Salute to Sir Isaac Newton. Mr. Sir Isaac Newton. I wish I could be friends with him. I would put him on my Facebook. I would add him as a friend. I would follow his tweets. Mr. Sir Isaac Newton. All right, this is it. That's the idea. One little idea, man. That's all it took, and it changes the way we solve equations. All these other things that are nearly impossible to do, everything here, child's play. Because all you got to do is find a derivative. If you can find a derivative and evaluate a point, boom, you can get a line. And if you can get a line over and over again, you're set. That's what it boils down to. Amazing, amazing idea. And it was all one little tiny idea. Hey, follow that line. It's leading you to the right place. It doesn't always work. I'll tell you some of the quirks later. But when it does, it's very, very nice. Actually, I don't like doing it. It's grunt work, but I love the idea. Anyways, talk is cheap. You guys want to do it? Let's actually do it. Why don't we solve some tough business equation problems? You guys want to do that? Suppose I got three solutions. I got this one, I got that one, and I got another one over there. But we'll deal with that later. Let's find this one first. I'm going to put my goal on finding that one right there, which is pretty close to 2. Right? Or pretty close to 1.5. So either one will work. If I start at, think about what would happen if I started at 1.5. This will give me a tangent line from here that way, and then it'll point me that way, and then here it'll take me here. Whoa! You know what? I'm tired of talking about it. Let's do it. Tired of talking about it. Talk is cheap. All right, I'm set. Are you guys ready? You got your game face on? Let's go with white on this. So right here at that point, I want the tangent line. I want it. I need it. I need to have a tangent line. So here's what I'm going to do. I'm going to try the general format. My first tangent line is always given by f of the point here, which will be 1.5. See, I'm choosing 1.5. It's my starting point. Plus f prime of 1.5 times x minus 1.5. Yeah. For that, I'm going to need some stuff here. I'm going to need to figure out how to figure out f and f prime. I got my f here. F of x is equal to 3 minus 5x plus x to the third. That's just the equation. My f prime, we are black belts at derivatives by now, would be 3x squared. That'd be funny if I make a mistake on this one. Yeah, that's good. Okay, so here I'm going to have to take this 1.5 and plug it into my function right here. 3 minus 5 times 1.5 plus 1.5 to the third. That would give me the first point here for the first part of my line, and then I'm going to have to plug it into here to figure out the rest of the equation of the line. So I did some preliminary work here. If I plug it into the equation, that's this one right here. Compare it. 3 minus 5, 1.5 plus 1.5 to the third. What is that equal to? That's negative 1.5. So this is negative 1 point, sorry, I might have said it wrong. P1 of x is equal to negative 1.25 plus, then you want to do this one. So you want to plug it into here. No, clear everything. Clear. I want to plug it into here. Negative 5 plus 3 times 1.5 squared. And that gives you 1.75. That's that number right there. And so we get, this is again 1.75. 1.75 times x minus 1.5. There you go. I've got my equation. My equation is negative, this whole thing. That's the equation for this line right here. Let me see if I could draw it. I'll draw it with the dashed. This is my first line right here. It's tangent and it's pointing me that way. It's telling me, hey, go that way, buddy. The solution is that way. Go that way. The next goal, of course, is to figure out this point right here. If this is my starting point, x1, then this is my second point here. I'll call this x2. And now the goal is, now the question is, how do I find x2? Well, the solution goes something like this. You know that This one is y is equal to 0, right? This is the x-axis. And you know that this one is y is equal to negative 1.25 plus 1.75 times x minus 1.5. That's this line right here. This line, y equals 0, has to intersect this line, y equals blah. These two have to be set equal to each other. That one and that one intersect right at that point. To figure out that point, you set them equal to each other. It's really easy. You just set it equal to 0, and that would give you that point. Let's do some of this grunt work somewhere else because I don't want to make it all dirty here.